The concept of this video is on standard normal distribution. So if you haven't watched a video or know about normal distribution, I would stop here and go backwards. But if you're here for standard normal distribution, you're at the right place. So standardized normal distribution is where it really affects this bottom part right here. No longer are we having a mean and a standard deviation that kind of changes these scores every time. These, on a standard normal distribution curve, these scores are the same no matter what. So what you'll notice is that the mean is now represented by 0 and the standard deviations are 1s. Okay? And the purpose of this is so that we can find or calculate the area or the perimeter probability, of any point. Okay, so at first we're going to have different values that we're given, and we're asked to or different values at the bottom that we're given, and we're asked to find the area of, and then we're going to be given data points. And when we're given data points, we have to change those into these standardized scores. And so first I should say that those standardized scores, these are called z-scores. So we have to be able to change or go in and out of z-scores to data points. And this formula here is the way to do that. So the x in the formula represents the data point that we're interested in. The mu symbol, remember, means the mean, and this theta symbol means the standard deviation. Or not standard, not theta, but omega, standard deviation. Okay, so in this situation, this formula walks us through how to go from z-score to data point or data point to z-score. So let's go ahead and take a look at an example of what we would have to do here. So starting with just z-scores, there's really 3 situations of what you would have to do in terms of area. So the first is where you're given a score and you're asked to calculate something less than that score. So what you're going to do here is you're going to find where negative 1.83 is approximately. So let's say it's there. And if I want it to be less than, then I'm going to the left. So I'm going to go ahead and highlight this section. So this is where, on the curve, the less than area of that point, all right? So now I need to use my calculator to kind of calculate this area, because this is not a calculation you'll do by hand. The thing you need to understand is that this could technically be shaded all the way towards negative infinity. That's hard to represent. So right now we're just picking a number that's really far to the left. Negative 5 is pretty good because it's super, I mean, that's so far away from the mean that really you're going to have most of your data within that point. So we're going to go into Desmos, and we're going to represent our left and right points with A and B. So A is going to be my farthest left point. So remember, for right now, we're using negative 5 as that far, far left. And remember that our far right is our actual value there, which was negative 1.83. So once I do that in my calculator, you can see on line 7, it lists the probability as 0.003, right? So if I go ahead and put that in, 0.033, and I multiply that by 100 to change it into a percent, this becomes 3.3%, okay? So the area from less than that z-score of negative 1.83 and to the left, that's going to give me that percentage. The second situation is where you're given a z-score, but you're asked to be greater than that, right? So 2.18, let's say, is right here, and that's going to go this way on the curve. So if I'm greater than, remember, I'm going towards the right, and again, that's going towards positive infinity, but that's hard to represent. So for right now, we're going to use the number 5. So if we were to, go into our Desmos calculator, we are using our 2.18 as our first boundary line, and our second we're using as 5. So remember, I hope you notice that with A and B, I'm going left to right. So A is always my farthest left point, and B is always my farthest right point. So I can see here 0.014. So if I go back here, 0.014 times 100 gives me 1.4%. And again, this makes sense. This is over 2 standard deviations away. This is going to be a very small percentage. The third situation is where you have this idea here where you're going between 2 scores. So with this one, 1.42, let's say, is right here, and 2.68 is right here. So I just want to know this section here between these 2 scores. So this is you're just going to put these two in 1.42, I think, right? 1.42 and 2.68. So here, 2.68, and again, I can see after I multiply by 100, about 7.4%. Okay, so here is kind of your 3 situations. You've got greater than, you've got less than, and then you've got in between. And just remember that you go left to right. So in that Desmos calculator, A is the left point and B is the right point. If you're struggling with that, I mean, mark them with your hands. Your left hand is going to your left point, your right hand is going to your right point. So that's how it works when you're given the z-scores. But what if you're not given the z-scores? What if you're given like actual values to kind of to go off of, right? So let's do this one right here. So let's say, for example, you were given this situation here where you're given the mean and you're given the standard deviation. But remember, we're standardizing this. So if I really wanted to do this, my values are 1, 2, and 3, and -1, -2, and -3. Okay, so I need to figure out where 12.64 is on this standardized curve. So this is where we're going to use that formula, okay? So remember, x is the data point, which is the 12.64. The mean is 12.4. And the standard deviation is 0.15. So when I do that, when I calculate that out, right, I get 1.6. So my z-score is 1.6. So the next thing I'm going to do is find 1.6 on my graph and mark it. Say it's about right there. And then I have to kind of figure out, do I want, in between something, less than, greater than, and this says less than. So I'm looking at all of this area. So first, just in the grand scheme of things, this is a large area. This number is going to be larger than 50%. It's a lot bigger than the actual curve. So this is the things I'm kind of thinking about. So when I remember, this is going towards negative infinity. So when I go into my Desmos calculator, I'm typing in -5 to represent negative infinity, and I'm typing in 1.6. 6 on my b value, and I can see this probability is high, or this area is high. It's 94.5%. Okay, so essentially 94.5% of chips would have less than 12.64 ounces. All right. And you can see this kind of continues. This one's asking between 12.1 and 12.76. So again, like on this, you would again do the same thing, 12.1 minus 12.4 divided by 0.5, right? And then same thing, 12.76 minus 12.4 divided by 0.15. And you're doing kind of the in-between one on this. So it doesn't matter if you already have the z-scores or if you need to calculate them, right? You have a data point. You're just kind of figuring out what that z-score is, and then figuring out, is it less than? Is it greater than, or is it in between? Sometimes it can be on the outside, which is just the opposite of the in between, but this gives you the basic idea of how you're setting this up. If this video was at all confusing, or if you have any questions,